Hello everyone, welcome back. So today we are moving one step further with DFA optimization. As already discussed, we have already converted the regular expression to NFA and NFA to DFA. Now an essential process that simplifies the DFA that we have converted from NFA. So why do we need this optimization? See, well, when we convert an NFA to DFA, sometimes we end up with redundant states, okay, which will add our unnecessary complexity to our automata. So DFA optimization helps us to reduce these states, making the DFA more efficient, faster to process, and easier to implement in real-world applications. So in this session, we'll explain the different steps to minimize the DFA using the state minimization technique. So the first step is to identify the distinguishable and equivalent states. See, we start by making the states which will have some different behaviors. Okay, for an example, such as one being an accepting state and another one is not an accepting state. Okay, so that will be distinguishable states, and inside the distinguishable states we will also have some equivalent states. Okay, so this distinguishable states cannot be merged, right? In the second step, we'll see the partition states into the group. So we'll group the states based on the similarities. Okay, for example, all accepting states might be grouped together and all non-accepting states is grouped in the another group. So we then check, and then we check that within each group if there any equivalent transition exists or not. Don't worry, I'll explain you an example. With that, all the steps will be clear. In the next step, we'll merge the equivalent state. So once we identify the states with identical transitions, we can merge them, so we reduce the overall number of states, and that's what makes a DFA optimized. Then we can create the optimized DFA. So after combining all the possible states, we construct a cleaner optimized DFA with fewer states and simple transitions. So now I'll walk through an example to make this process clearer. So as discussed already, we have constructed a DFA from NFA earlier. I'll take the same example. Its transition table was, I'll just draw a transition table here because we need the states and its transitions. So this is states A, B. What was my state? A, B, C, D and E. Okay, so I have taken the previous example for which we have converted NFA to DFA. So we already have this transition table. So for DFA optimization, our first step is to separate the accepting states and non-accepting states. See, our accepting state was what? E, right? Our accepting state was what? E, right? So we'll separate the accepting states and non-accepting states. What are the non-accepting states? So A, B, C and D, and then accepting state is E. So this will be my zero equivalence. Okay, zero equivalence. In the second step, we need to find the one equivalence. See, now after finding the zero equivalence, our all subsequent equivalence will be found, or you can say it will be formed by checking if there is an equivalent transition that exists between the elements or between the states of this group. Okay, let's say we will just pair and see their equivalents. Okay, see, I'll start with A, B, C and then D. See, from A I can transit to B and C. Now this B and C already exist in this group. Yes, so A will be a part of this group. So I'll write A. Same way you have to check for B. B can transit to B and D. B and D exist in this group. Yes, so B is a part of this group. Same way C. From C we can transit to B and C. So B and C already exist in this group. Yes, so this will be a part of the new group. So C. Then from D we can transit to B and E. So B and E are group of this part of this group? No. So we will separate this D into another group. So this will form my one equivalence. Same way you need to repeat this. See, I am not getting any other elements in the group, or you can say any other states in this group, therefore I am not checking the equivalent transitions between this. Okay, if you have one or more elements in this, then you need to check the equivalent transition as we are checking in this first equivalence for this group. Okay, so same way you are checking for this group, you need to do this for the accepting group also if you have the elements. But here I don't have the elements in the example, therefore I am not calculating the equivalent transitions. Similarly, so in the two equivalents, or you can say second equivalence, what we will get, now we need to do this or find this equivalent transitions for A, B and C, this group. Okay, because this has the single elements. So let's see for A, B and C. So similarly we'll find again, this is my group, right? First we'll start with A. So from A we can transit to B and C, and from B we can transit to B and D, and from C we can transit to B and C. Now see, B and C are a part of this group. Yes. B and D are a part of this group. No, D is not a part of this group. As D is not a part of this group, we'll separate this D into another group. So my two equivalents will be A, B will not be a part now, C. So B, D and E. Now what we can do is next equivalence. So we will find the next equivalence. Let's see for 3. Same way we can find for 3 equivalents. Now see, the only group which has one or more element is A, C, because B, D and E have the single elements in that group. So we'll start for this group A and C. See, A is having B and C, and from B, okay, see, when we see that A can transit to B and C, and C can transit to B and C, and we don't find B in this group. But see, whenever you find same transitions, okay, then they are said to be have equivalent transitions. Okay, transition, they are said to be transition equivalent. So we don't separate this group, we don't split this group. Remember this is an important thing, because sometimes we are confused that A is transited from B and C and B does not exist in this group. So why we are not splitting this A and C? But we cannot split A and C because they both are transition equivalent. So this will remain same. And here we stop the optimization, and what we get is A is transition equivalent to C, or you can just write A is transition equivalent to C. So here in this transition table we can modify that. Instead of A we can write C, or instead of C we can write A. So instead of C we will write A. We stop this optimization process here because we get no more splitting here, right? So see, our transition table will be reduced to what? States and input symbols are A and B. What were my states? A, B, C will not be now considered, so D and E. And A, it will be translated to B. Instead of C I'll write A, B, D, instead of B, E, and here instead of C I'll write A. So this is my minimized, or you can say optimized DFA transition table. So when you construct an optimized DFA, see, I'll start with the initial state, that is A. A is my initial state. So A, with input A I can transit to B, and with input A I can transit to A itself. Similarly from B I can transit to B itself with input as A, and from B I can transit to D with input as B. So I can transit to B. Similarly from D I can transit to B when I have an input symbol as A, and from D I can transit to E when I have an input symbol as B, and from E I can transit to B when I have an input symbol as A and transit to A when I have an input symbol as B. So this is my minimized DFA, and I have only 4 states. In non-optimized DFA or the regular DFA which we got from NFA, that had only 5 states, which is now being optimized. So there you have it, a DFA optimization. So by trimming down the DFA, we create a cleaner and more efficient automata which is ready for our real world use. So this optimization is particularly useful for our compilers because processing speed and efficiency are the key concepts. So in our next session, we'll dive into RE to DFA conversion, that is converting your regular expression directly into DFA without converting them into NFA. Okay, this is a very foundational concept in lexical analysis because it brings us closer to understanding how the patterns are recognized within the source code, right? So if you have any questions about DFA optimization or if anything wasn't clear, feel free to drop a comment, and I'll see you all in the next session for RE to DFA conversion. Thank you.